Hey guys, good morning. Will here, CFM. I wanted to take a moment and tell you guys the three basic types of motors that you'll find in most residential HVAC furnaces, air handlers, equipment. The first is the most basic. It's a PSE motor, permanent split capacitor, PSC motor. And that is the most basic type of motor that you're probably most familiar with. The second motor is a step up from the PSE. The advantages to this motor are that it is a soft start motor. It is also still a constant torque motor. It is known as a standard ECM blower motor or an X13 blower motor. This motor commonly has line voltage supplied to it at all times and modulates its power based off a 24 volt input from the control board. So rather than having a PSE motor that has 120 volts input to it to select its speed, an X13 or standard ECM motor almost operates more like a relay, has high voltage power going to it constantly, and then the 24 volt closure from the X13 blower motor or the control board closes the contacts internal to the motor, allowing the motor to start up and run at the selected speed. There are some huge advantages to this motor. Its cost is very competitive. There are universal replacements out there from Azure, from Evergreen, and some others. We do sell those at all of our branch locations. The last motor is a true variable ECM. ECM stands for electronically commutated motor, so ECM. And a true ECM motor will have typically 16 wires going to it, a 16 wire plug or a Molex plug that has 16 wires in it. And this is, rather than being a constant torque motor, it is a constant CFM motor. So it will try to deliver the proper amount of CFM no matter what the static pressure. And the static pressure is the resistance on the furnace or air handler. It's the ductwork resistance, it's the filter resistance, it's all the junk stacked on top of the return air register. You got all those homeowners that do that. But the ECM, or the electrically commutated motor, the true ECM, is a constant CFM motor, which is why the motor will typically speed down or slow down when you remove the door from a furnace cabinet. That's because it doesn't have to work as hard to deliver the desired amount of CFM. So this is a great feature of an ECM motor, but also it can kind of get us into trouble sometimes because some people will use these ECM motors as a fixed solution when really what needs to be happening is the ductwork needs to be modified in order to deliver the appropriate amount of airflow. So be careful when we're doing that. All of our furnaces and York equipment is rated for, residentially, is rated for 0.5 or 1/2 inch of total external static pressure. So anything over that, we're going to derate the airflow rating on the furnace. So let's say that you have a 5-ton drive blower motor. If you're at a 0.6 or 0.6 of an inch of static pressure, it's going to be, there's probably no way you're going to be able to deliver the amount of airflow that's rated on that furnace. So definitely keep that in mind as you guys are sizing equipment and picking blower options. So like I said, three types of motors: permanent split capacitor, PSC, X13 or standard ECM is a step up from that, and then the highest end motor that we sell in most of our residential high-end equipment is a ECM, electronically commutated motor. So if you have any questions on this, or you want to know more about ECMs or X13s, please reach out to us. We'd love to help and answer any questions that you might have. We will be putting on classes explaining the different types of motor, how to diagnose them. But if you have questions, drop me a comment or shoot me a message, and I would be glad to answer any of your questions. Better yet, put it in the comments, because if you're asking the question, somebody else is as well. So let's all learn from this, and I'm looking forward to hearing all you guys' questions, and let's talk. Thanks.